Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about definite integrals, right? So till now we have been doing indefinite integrals wherein we had no limit on any function. So we said f of x squared dot dx is actually equal to x cubed over 3 plus c. So that means we didn't have any lower bound or any upper bound here. However, now what we're going to do is we're going to define what are definite integrals. So we're going to be defining what are definite integrals. Now, definite integrals have a lower bound. They have a lower bound as well as they have the upper bound. So what you have is you have your integral sign here. This is where your lower bound comes, and this is where your upper bound comes, and then you have the value of you want to find the integral of antiderivative of f of x of dx. So let's suppose the integral of f of x dot dx is capital Fx, and then what you have to do is you have to find the value of this from the lower bound to the upper bound, right? Let's suppose the lower bound is a and the upper bound is b. So what you'll do is you'll find the value of f of b and you'll subtract the value of f of b from f of a, right? So this is what you're going to do. This tells you the value of the integral from the lower bound to the upper bound. Now, I'm not going to do the geometric representation of this yet. I will do the geometric representation in a later video. But right now, what you have to understand is that if you have to find the value of the integral, so the value of the integral is something that can be found by subtracting the upper bound with the lower bound. Let's take an example, right? So let's say that the example is I want to find out the value of this integral here, f1 over x dot dx from 3 all the way till 5. So first of all, what will I do is I'll find out the integral. So the integral of antiderivative of 1 by x is actually going to be equal to log of x, right? And that is actually going to be equal to log of 5 minus log of 3, so which is actually going to be equal to log of 5 over 3 to the base e. So that means this is the value of this integral over here. Now you must be wondering, where is the constant, right? So you must be wondering, where is the constant? Well, constant is something which is cancelled out in our difference here, in subtraction here, because when we find the value of log of x from 5 and 3, so that, and plus we definitely have to add c here. So what happens is we have log of 5 plus c, and then we have log of 3 minus c. So this c and this c gets cancelled out always. Even if you check it out here, I have to find the integral of f of b minus f of a. That is what I have to do. So this will give me an plus constant, and this will give me a negative constant, and the constant and constant will get cancelled out. So the constant gets cancelled out when we find the value of the definite integral. Fine. So suppose you're understanding this point over here. Let's go ahead and pick up a question. Let's suppose we want to find out the integral of this function over here, right? So let's suppose we want to find out the integral of this function. So first of all, what we'll do is we will find out the antiderivative first, keeping the lower and upper bound here. So the antiderivative of e raised to power 2x is actually going to be equal to it's actually going to be equal to 1 by 2 into e raised to power 2x, because I have to take care of this 2 first. Then it's going to be plus 3 into this, so that's going to be log of x plus 1. Fine. So what I have to do now is I'll just have to, and this is to the base e always, and then I'll have to find the upper limit minus the lower limit. So it's going to be e raised to the power 2 into 1 over 2 plus 3 into log of 1 plus 1, which is 2, minus 1 by 2 into e raised to the power 0 minus 3 into log of 1. Fine. So that means this is the value of this integral here. I'm not talking about the geometric representation of this. I'm just showing you the formula. How is it done? We're going to be talking about in the next video. So I suppose you're understanding this this value over here. You're able to understand what I'm trying to say. So what I'm going to do is I'm going to tell you the properties of definite integrals. So the first property is that the integral from a till a of any function is actually equal to 0. So the integral from a to f of any function is equal to 0, because what you're going to have here is you're going to have f of x from a to a, which will actually come down to be f of a minus f of a, which is always going to be equal to 0. So that means this is the first property, that's the integral from a to a is something which is equal to 0. Another property is that the integral from a to b of any function is actually equal to negative of integral from b to a of that same function. Right, so this is something again that we can validate. This over here is something which actually turns out to be equal to f of b minus f of a, means the antiderivative, and this is something which turns out to be f of a minus f of b. So that means you can clearly see that this is the negative of this integral. So this is something which is true all the time. Fine. And the next property is, the third property is that if you have an integral of a function, any function, let's suppose f of x dot dx from a till b, and let's suppose there is a value c which is actually less than or equal to b. This is actually between a and b, that's what I want to say, which is actually between a and b. Then you can say that the integral from a till c of f of dx plus the integral from c to b of f of x, the sum of both of them is actually going to be equal to this integral. So I'm going to repeat again, if there is a value c which is between a and b, then in the definite integral from a to b is equal to the sum of the definite integrals from a to c and c to b. Fine. So I suppose you're understanding this point over here. This is something that we can prove this with an example also. Let's suppose 2 and 5, I want to find out the integral of 1 by x dot dx. So that is simply going to be equal to log of 5 minus log of 2, which is equal to log of 5 over 2, which is log of 2.5. So let's suppose if I want to find out the integral from, let's say, 2 till 3 of 1 by x, and I add it from integral from 3 to 5 of 1 by x. So what I do is I just break 2 to 5 into two parts. So this is going to be equal to log of 3 minus log of 2, which is this integral here. Then it's going to be equal to log of 5 minus log of 3. So as you can see that this and this is something which completely goes, and again I'm left with log of 5 minus log of 2, which is actually equal to log of 2.5. So again we're able to say this is a property for definite integrals. The next property is, which is property number 4, is that the integral of a constant into that function from a till b. So this is something which is very easy. You can actually take the constant out and just focus on the function itself. Fine. So such that the constant belongs to real numbers. So that is very important. So again, that's a very easy property. You don't need to even discuss more on that. You can always take the constant out. The next property, the fifth property, is that the integral from a to b of f of x plus or minus of any function dot dx is actually going to be equal to the individual integrals, right? So again, this is very easy, right? So that is equal to the individual integrals. Fine. So I suppose you're able to understand what I'm trying to say here, guys. This is very easy. All we have done is we've just added definite integrals here rather than doing indefinite integrals. So that's there. So thank you very much for watching this video, guys, and this is our website address, our Facebook page to give us a valuable like, our email address to give us a valuable feedback. So thank you very much for watching, guys. I'll see you in the next one.